Foundations provide support to the structure and transport the loads from the structure to the soil. However, the layer at which the foundation transports the load shall have an adequate bearing capacity and suitable settlement characteristics. There are several types of foundations depending on various considerations such as total load from the superstructure, soil conditions, water level, noise and vibration sensitivity, available resources, the time frame of the project, and finally cost. So foundations are classified as shallow foundation and deep foundation. Shallow footings are usually used when the bearing capacity of the surface soil is adequate to carry the loads imposed by a structure. On the other hand, different types of deep foundations are usually used when the bearing capacity of the surface soil is not sufficient to carry the loads imposed by a structure. So, what is a pile foundation? A pile foundation is a kind of deep foundation that can be defined as a slender column or long cylinder made of materials such as concrete or steel, which are used to support the structure and transfer the load at desired depth either by end bearing or skin friction. Pile foundations are deep foundations. They are formed by long, slender, columnar elements typically made from steel or reinforced concrete or sometimes timber. A foundation is described as piled when its depth is more than 3 times its breadth. Foundation piles are usually used for large structures and in situations where the soil at the shallow depth is not suitable to resist excessive settlement, resist uplift, etc. When to use pile foundation? When the groundwater table is high, foundation filings are the best solution. Heavy and ununiform loads from the superstructure are imposed. Other types of foundations are costlier or not feasible. When the soil at shallow depth is compressible, when there is a possibility of scouring due to its location near the riverbed or seashore, when there is a canal or deep drainage system near the structure, when the soil excavation is not possible up to the desired depth due to poor soil conditions, when it becomes impossible to keep the foundation trenches dry by pumping or by any other measures due to heavy inflow of seepage. Types of pile foundation. Piling foundations can be classified based on function, material installation process, etc. The following are the types of foundation used in construction. So based on function or use, we have seat piles, load bearing piles, end bearing piles, friction piles, and soil compactor piles. Based on materials and construction method, we have timber piles, concrete piles, steel piles, and composite piles. Sheet piles. This type of pile is mostly used to provide lateral support. Usually they resist lateral pressure from loose soil, the flow of water. They are usually used for cofferdams, trench sitting, shore protection. They are not used for providing vertical support to the structure. They are usually used to serve the following purposes: construction of retaining walls, protection from river bank erosion, retain the loose soil around the foundation trenches, for isolation of foundation from adjacent soils, for confinement of soil and thus increase the bearing capacity of the soil. Load bearing piles. This type of building pile foundation is mainly used to transfer the vertical loads from the structure to the soil. This load bearing pile foundation transmit loads through the soil with poor supporting property onto a layer that is capable of bearing the load. Depending on the mechanism of load transfer from pile to the soil, load bearing piles can be further classified as followed. End bearing piles. In this type of pile foundation, the loads pass through the lower tip of the pile. The bottom end of the end bearing pile rests on a strong layer or soil or rock. Usually the pile rests at a transition layer of weak and strong layer. As a result, the pile acts as a column and safely transfers the load to the strong layer. The total capacity of the end bearing pile foundation can be calculated by multiplying the area of the tip of the pile and the bearing capacity at that particular depth of soil at which the pile rests. Considering a regional factor of safety, the diameter of the pile is calculated. Friction pile. The friction pile transfers the load from the structure to the soil by the frictional force between the surface of the pile and the soil surrounding the pile, such as steep clay, sandy clay, etc. Friction can be developed for the entire length of the pile or a definite length of the pile depending on the strata of the soil. In friction piles, generally the entire surface of the pile works to transfer the load from the structure to the soil. The surface area of the pile multiplied by the safe friction force developed per unit area determines the capacity of the pile. Soil compactor piles. Unlike other pile foundation types, this type of pile does not carry any direct load. This type of pile is driven at placed closed intervals to increase the bearing capacity of the soil by compacting. Types of piles based on material and pile foundation construction method. Primarily, piles can be classified into two parts: displacement piles and non-displacement or replacement piles. Piles that cause the soil to be displaced vertically and radially as they are driven to the ground are known as displacement piles. In the case of replacement piles, the ground is bored and the soil is removed, and then the resulting hole is either filled with concrete or a precast concrete pile is inserted. On the basis of materials of pile foundation, construction and their installation process, load-bearing piles can be classified as follows: timber piles, untreated, treated with preservative; concrete piles, precast piles, cast-in-place piles; steel piles, I-section piles, hollow piles; then composite piles. Timber piles. Timber piles are the types of pile foundation that are placed under the water level. They last for approximately about 30 years. They can be rectangular or circular in shape. Their diameter or size can vary from 12 to 16 inches. The length of the pile is usually 20 times the top width. They are usually designed for 15 to 20 tons. Additional strength can be obtained by bolting fish plates to the side of the piles. Advantages of timber piles. Timber piles of regular size are available, economical, easy to install, low possibility of damage. Timber pile footings can be cut off at any desired length after installation. If necessary, timber piles can be easily pulled out. Disadvantages of timber piles. Piles of longer lengths are not always available. It is difficult to obtain straight piles if the length is short. It is difficult to drive the pile if the soil strata are very hard. Spicing of timber piles is difficult. Timber or wooden piles are not suitable to be used as end-bearing piles. For the durability of timber piles, special measures have to be taken. For example, wooden piles are often treated with preservatives. Concrete piles. Precast concrete pile. The precast concrete pile foundation is cast in a pile bed in horizontal form if they are rectangular in shape. Usually, the circular piles are cast in vertical forms. Precast piles are usually reinforced with steel to prevent breakage during their mobilization from the casting bed to the location of the foundation. After the piles are cast, curing has to be performed as per specification. Generally, curing period for precast piles is 21 to 28 days. Advantages of precast piles. It provides high resistance to chemical and biological cracks. They are usually of high strength. To facilitate driving, a pipe may be installed along the center of the pile. If the piles are cast and ready to be driven before the installation phase is due, it can increase the pace of the work. The confinement of the reinforcement can be ensured. The quality of the pile can be controlled. If any fault is identified, it can be replaced before driving. Precast piles can be driven under the water. The piles can be loaded immediately after it is driven up to the required length. Disadvantages of precast piles. Once the length of the pile is decided, it is difficult to increase or decrease the length of the pile afterward. They are difficult to mobilize, needs heavy and expensive equipment to drive. As they are not available for ready-made purchase, it can cause a delay in the project. There is a possibility of breakage or damage during the handling and driving of piles. Cast in place concrete piles. This type of pile footing is constructed by boring soil up to the desired depth and then depositing freshly mixed concrete in that place and letting it to be cured there. Cast in situ concrete pile foundation is constructed either by driving a metallic shell to the ground and filling it with concrete and leaving the shell with the concrete, or the shell is pulled out while concrete is poured. Usually round piles are used in cast in situ piling. Advantages. The shells are lightweight, so they are easy to handle. The length of the piles can be varied easily. The shells may be assembled at site. No excess enforcement is required, only to prevent damage from handling. No possibility of breaking during installation. Additional piles can be provided easily if required. Disadvantages. In this type of pile foundation, installation requires careful supervision and quality control. It needs sufficient place on site for storage of the materials used for construction. It is difficult to construct cast in situ piles where the underground water flow is heavy. The bottom of the pile may not be symmetrical. If the pile is unreinforced and uncased, the pile can fail in tension if there acts an uplifting force. Steel piles. Steel piles may be of I section or hollow pipe. They are filled with concrete. The size may vary from 10 inches to 24 inches in diameter, and the thickness is usually 3 by 4 inches. Because of the small sectional area, the piles are easy to drive. They are mostly used as end bearing piles. Advantages. They are easy to install. They can reach a greater depth compared to any other type of pile, can penetrate through the hard layer of the soil due to the less cross-sectional area. It is easy to splice steel piles and it can carry heavy loads. Disadvantages of steel piles. This piling type is prone to corrosion. It has a possibility of deviating while driving, comparatively expensive.